Welcome back to my channel. Forgive me for having to split this up into two parts, but my computer shows low quality, and let's just leave it there, and let's get back to the fun, shall we?
My God, you're so stupid.
No, when I click on it, there's no pin option.
You are useless. That's
Okay.
literally how
you know
Zoom
what?
works.
Just send the link later. Just send the link later. Anyway, the point is that the image that is being shown, whether you can and can't see whatever, all of these images, all these individual images were taken with an equatorial telescope mount. And when these images were taken, only one axis was moving. So if we were to model that on a flat Earth, what you would see is that these images would be impossible. In order to keep anything in frame, you would have to rotate not one, but two axes.
You model it.
With the fact that equatorial
Earth?
telescope mounts work, why the fuck should we believe that the Earth is flat when it's geometrically impossible to work on a flat Earth?
Well, you said if you what flat Earth are you measuring? What's the parameters?
Any flat surface.
Oh my
Any
God.
flat surface. You put this telescope on any flat surface, it will not work, period.
What are you talking about?
I love it when these two get people to stammer. Well, I love that. It works.
You just point it up at the sky and take a picture.
That's not
Yeah,
how it works.
unfortunately, it's not what we're viewing, it's how we're viewing it. We are rotating only one axis in order to get these really epic and badass shots, which, by the way, I just shared in the live chat. The fact that we're able to get these images in the manner that they were gotten illustrates the shape of the Earth. The illustration shows that when you model this out, it doesn't work on a flat surface, but it does work on a curved surface. Imagine that. So please explain the geometric inconsistency that is the flat Earth if the Earth really is flat.
I'm still waiting for you guys to prove your radius. You guys,
It's been measured. We keep telling you it's been measured.
You are sidestepping my question.
It doesn't need to be proven. It has already been proven.
And sidestepping to a different subject. I'm not going to let you get away from this. Please explain
you keep talking about
the
geometric
inconsistency that is these observations, given the fact that you believe that the Earth is a flat surface.
You keep talking. You keep saying geometry. I need you to prove geometry first. That's your claim.
Yeah. There you go. Here's a picture of the entire Earth from
I have
space.
I have all of these images that show exactly what is working. And here's the thing: only one shape works with the way these images were taken. A curved Earth. That proves the geometry. So please tell me how this proves a flat Earth, given the geometric inconsistencies.
So
given
you're
the
assuming
geometric
a radius.
contradiction, I should say.
No,
No, we're not assuming anything. No, look, hold on, stop. Shh, let me speak. I just told you to let me speak. Stop. Thank you. Right, we're not assuming anything. Here's a picture of it.
That's
from space.
That's the picture.
Yeah,
that's a picture.
That's a picture of the entire Earth. That's the geometry of Earth. You keep asking for the geometry of Earth. There is a picture of the entire Earth. It is curved. Do you see the curve in that picture? Yes or no?
Well, that's a.
Do you see? No, direct question. Do you see the curve in that picture? Yes or no?
That's not Earth.
Do you see the curve in that picture? Yes or no?
Well, in the picture, yes.
Yeah, and that is Earth. So there you go.
Well, it's not because
I don't care if you say it's not. That is Earth. That is Earth.
You said this whole show that you don't see the geometric horizon. Do you know?
Not if you're within the atmosphere. No. Is this picture taken from within the atmosphere? No, it's not.
It's a geometric.
This guy exhibits an epic amount of denialism.
Horizon, the curve of the Earth.
No, it's caused by the curve of the Earth.
So the geometric horizon, geometric, that's your geometry, is not the curve of the Earth. So your
Look at the
geometry
picture in front of you. That is the shape of the Earth.
the curve.
The picture in front of you
That's
is
the
the shape
picture.
of the Earth.
Well, that's what you say it is.
No, that's what it is. It's your burden to prove that it's not.
No, it's your burden to prove
No, it's
that
not.
picture.
No, this has been replicated many times. It was developed in a dark room from a physical camera. Our burden has been absolutely met. It is your burden. If you are saying this proof, if you are saying that, shut up, I'm talking. If you are saying that this is fake or is not an actual picture of the Earth, it is now your burden to back up that claim.
No, you're the one who's making the claim.
No. It's been it's been replicated. It's been replicated many times. On this mission, it was replicated. Shut up, I'm talking. On this mission, it was replicated many times. It has been replicated. It's been done. You are the one that's claiming all those replications of a picture like this are not real. Therefore, you have to demonstrate them to be not real.
I'm still waiting for you to demonstrate that those are real.
No, I just told you it's been replicated. It was physically on a camera and developed in a dark room. That is the evidence that it is real.
No, it's not. If that's evidence to you,
Well, right there when he said no, it's not, he should have asked Bumpy Nipples there to prove that it wasn't. But
it's actual evidence.
Okay.
It's a picture of the entire Earth. It's evidence.
Okay, but it's not proof. It's not 100%
No,
fact.
science doesn't prove anything. It is 100% fact.
So,
it absolutely is 100%.
time for word games again. I'm just gonna let this play for a while.
But
it is 100. It is 100%. Shut up. It is 100% a fact. Science proves nothing.
But it proves your globe.
No, science doesn't prove anything.
So all right, so that's not 100% fact then.
Yes, it is.
How? When you said science doesn't prove anything, but you're saying that this is true. You're saying science has proved the Earth is a globe.
I'd say science does not prove anything. That's not what science is for.
It provides evidence.
So
it provides evidence. It leads us towards a certain answer. And based on how much evidence we have, it illustrates our confidence in that answer.
So there's no scientific
an intellectually
fact.
honest way of navigating the natural world. I'm sorry you're not accustomed to it.
So there's no scientific fact that the Earth is a globe.
Yes, there's scientific facts.
There is scientific facts that go into the globe hypothesis, yes, including the fact that, I don't know, we fucking took a picture of it, but you guys don't accept that, so fuck us, I guess.
But science doesn't prove everything. Okay?
Yeah, facts and proof aren't the same thing.
There's no scientific proof that the Earth is a globe.
There's no scientific proof of anything ever.
So, then why even debate?
Because proof doesn't mean what you think it does. Proof is in the maths, and there is proof that the Earth is a globe.
Said science. So there's no scientific proof.
There's no scientific proof at all, ever. But let me finish what I'm saying. Let me finish what I am saying. There is no scientific proof of anything ever in existence. You do not get scientific proof. That is not a thing that exists. However, there is actual proof that the Earth is a globe.
Actual proof?
Yes.
What's the difference between actual and scientific?
You don't get proof in science. It's as simple as that. Proof means exactly what it means. And do you know where you get proof from?
Go ahead.
Math? Yes. That is where proof comes from.
So your globe only exists in math?
No, not at all. There's in so much scientific evidence to suggest that the Earth is a globe. And there is also an incredible amount of mathematical proof to suggest that the Earth is a globe. There are physical laws of nature to suggest that the Earth is a globe. All the evidence suggests that the Earth is a globe.
So, because of all that, that means that the Earth is a globe.
Oh, that's what the evidence suggests, yes.
But it still might not be, because
There's no evidence to suggest that.
There's no scientific evidence that's fact.
No, I didn't say that. There is scientific evidence and there is scientific fact, but there is no scientific proof because scientific proof does not exist.
Man, this guy likes to play word games and switchboard proofs and he fucking fallacies all over himself. That's basically what he has done, pretty much. I mean, that's pretty much what he has done throughout all the debates that I have seen this guy in. He fumbles and stumbles and fallacies, and it's just embarrassing.
If you are talking about scientific proof, you are talking about pseudoscience. That is the only kind of science that deals with proof, pseudoscience. Are you a practitioner of pseudoscience?
What's the difference between scientific fact?
Are you a practitioner of pseudoscience, yes or no?
No.
Right. Do you think science proves things?
Do I?
Yeah.
Yeah, I think so.
Then you are practicing pseudoscience.
Hey, Greg, can I show something?
Yes, sure.
Okay, I'm going to share my screen. So if you can grant access to me, that'd be great.
Oh, yes, sugar, I do need to do that.
Yeah, thank you. I would appreciate that. Thank you.
Come on. I'm trying to figure out how to do it. Oh, there we go. Allow participants to share screen. There you go. You should be able to do it now.
Okay, I'm sharing my screens right now. Let me know if it comes through.
Yes. I will bring that
All right,
so
perfect.
everybody can see
The
it.
program that you're looking at is called GeoGebra Classic 5. It's very, very useful. I recommend you download it. Anyway, what I have done is I have drawn a circle here. Obvious. Put the center in the middle, obvious, and I have two observers on the surface. Both of these observers...
But you're begging the question.
You don't know what that means. Shut up.
Both of these observers
Shut up.
are using equatorial telescope mounts. Now, what they're doing is they're looking at an object called star. As you can see, I put it way the fuck away. So the star is very, very far away. But in order to view that star, they have to angle their equatorial telescope mounts a certain amount, depending on where they are on the surface of the Earth. So this individual, in order to see the star, would have to bend his scope, bend the axis of the equatorial mount, 25-something degrees. This one would be 60.43 degrees. And so if I were to adjust where these observers are, you would get different altitude angles for the axis of rotation of their telescopes. So it turns out that the further you are away from the North Pole, the greater the angle of deflection, almost as if it's on a curved surface. So when we actually look at the amount of angle of deflection, not only does it point to the fact that the Earth is round, but it also points to the size of the Earth. You cannot get this angle at this distance away from the North Pole without it being a sphere of the right size. You can measure this yourself with an equatorial telescope mount. So, an equatorial telescope mount, to be clear, not only confirms the shape of the Earth, but also the size of the Earth. By modeling out like this, you can measure the distance, which is r. Imagine that.
No assumptions needed.
No assumptions needed. This is something you can do in reality.
There isn't assumptions needed. You just put a circle on a graph. You said
no,
this
he didn't.
is reality.
No, he didn't.
Yes.
No, he didn't.
Yeah.
He mapped out data.
You know what an illustration is, dude? Do you really know what an illustration is?
I do.
Stop asking stupid fucking questions.
What Red showed you there was actually an example of proof, right? What Red showed you was a proof, a mathematical proof. That is what proof is. What Red showed you proves the Earth is a globe.
Does that illustration show the geometric horizon?
For fuck's sake, you asked about R. You asked about R. What I was demonstrating there is that not only do equatorial telescope mounts demonstrate themselves to not work on a flat Earth, but they confirm the shape of our Earth and also its size. You said, well, I need a measurement for R. How do you get R? That's a way we get R. If you were to plot this out using real life examples, you can figure out the radius of the Earth, which means you would be able to figure out the circumference of the Earth because pi is a thing.
You're assuming that the Earth is a globe.
Oh, please say I'm assuming pi. Please say I'm assuming pi. I will laugh my ass off.
You put a circle on that graph.
No assumptions made.
Come from?
Illustration. It claimed by me clicking a few buttons, dumbass.
Yeah,
it's an illustration.
But it also the parameters of that particular thing, the parameters of that circle would be based on the angles that were gathered from those two separate equatorial mounts, right? And when you map that data, let me finish. When you map that data onto a graphing computer like Reds has shown, it shows you what it must be attached to based on the angles that you had. There is no assumptions made, none at all. Unless you are saying that a squared plus b squared doesn't equal c squared, which would be fucking idiotic, then everything Red said there was proof that the Earth is a globe with a geometric horizon.
He's putting a circle on the graph before he
No, he's not. The graph did it.
The consequences of an equatorial mount is what I'm doing. You can do this with real life examples. We have done it. Many people have done it. Find a guy who's more north than you by a few hundred miles, who has an equatorial mount. Tell him to set it up properly so he can track shit. Ask another guy way further south than you to do the exact same thing, looking at the same object, setting it up properly, that is. And guess what? You will be able to use those two data points to figure out the shape of the surface you are standing on. That's what I was illustrating with that graphic.
Okay, if you didn't have the circle on the graph, where would you put those red markers for the?
You mean the observers?
Yeah.
We could put them anywhere, and you want to know what would happen if we did that with a flat Earth?
He was graphing it out on the surface, dude. He did it. Oh, fucking A. Has this guy ever seen a computer lab? I'm serious. I mean, he didn't fucking. I think it was. Fuck, I can't remember, but shit. In elementary school, I started working with computers. Fuck. I know it. 3. Whatever. This guy's just fucking. It's stupid.
Show you what would happen. What we would
put
get
them anywhere, but where would they be on that graph?
We could put them the same distance apart. We can put them the same distance apart. We can put them the same distance apart, and guess what? That will lead. We can put them the same distance apart, and that will
stop interrupting.
We can put them the same distance apart. And where that will lead us to,
off of what?
we can put them the same distance apart. And what that will lead to is a contradiction in the position of that star.
Distance? How'd you get the distance? How'd you know the distance?
You measure it.
Based off of what?
By driving.
You get in a car and you drive from point A to B.
Distance.
So, okay.
If you go north a certain distance,
how would you graph that out?
And you go south a certain distance, you can measure this out using the angles of the equatorial mount. But guess what? Unless you want to assert that my odometer is part of the conspiracy, I'm not going to believe your bullshit.
How would you graph that out without the circle?
How would I graph that out? Simple. You give me an angle for the equatorial mount at one location. You give me the angle of an equatorial mount at a different location. And what I will do is I will plot those points on a straight line the same distance apart. And you will see that the angles do not meet at a point. They, in fact, cross and go in different directions, i.e. there's a contradiction with the placement of the object they are looking at in the sky, which means there's a contradiction with the shape of the Earth that you're using to base them on.
Okay, prove that.
Okay, we can do that. We can do that. We can totally do that. Give me what is the best angle, Craig? Let me ask you this. I'm going to ask people in the live chat. Let's go ahead and prove this because apparently he hasn't done this himself. I would like somebody like, let's say in Canada or Maine or North Dakota, north, to give me the angle at which they set up their scope. Give me that angle. And what I will do is I will also ask people in the South, like Texas, Florida, Hawaii. If you have an equatorial mount, tell me the angle at which you set that scope. Once I get two values from reality, what I will do is I will plot that shit out, and you will see the contradiction for yourself.
Okay.
That's close. Now it's close. I hope I don't get booted for those ads. I hope these videos make it to publish, because this is good.
Well,
This is good
I'm waiting.
stuff.
Okay, so we have 53 degrees north in York, UK. So let me put that up right there.
So that's
53 degrees.
wait. 53 degrees north, based on what?
That's the latitude.
Latitude, which is assuming a globe.
Ontario is 63.
You know, there's latitudes on an equatorial.
You're assuming a globe.
No.
We're
There's
going to plot
on,
these out on a flat
latitude.
surface. We're going to plot these out on a flat surface.
I know. I just need to explain something. You know that latitudes and longitudes exist on an azimuthal equidistant map, right? They just are spread out more.
I didn't bring up any map. That's a straw man.
No, it's not. You said that the latitude and longitude are based on the globe. They're not. They're just positions. But when you map it out, you get a globe.
Flat Earth map?
No,
based on the flat Earth map?
No, I didn't say that, did I? I said that if you map them, they're not based on anything. They're not based on anything. There isn't. Shut up. There isn't any flat Earth map. There isn't any flat Earth maps. Okay, but flat maps like the azimuthal equidistant projection maps also have latitude and longitude on, which, when you go to the position, correspond to that. However, the distances going east to west on any map that is flat, that has latitude and longitude on, does not match reality. The only shape that matches reality when you map out longitude and latitude is a sphere. Do not strawman. No claims, that is a fact. I am a sailor. I have verified this myself.
Okay, so we have 42 degrees in South Oregon. I'll pick a city. So
you're basing this all off the globe.
Nope. I want you to hear me very clearly now.
What are you basing it
when we plot these out,
where longitude and latitude is.
When we plot these out, we will not plot them out on a curve. We will plot them out on a flat surface, and we will see if there is a contradiction. All right, I got someone in Oregon. Can I get?
Dude, even I know what longitude and latitude is. Longitude and longitude. That's what I said. Longitude and latitude. There we go. That's how you say it.
Someone in Florida or Hawaii or even Mexico, some shit like that.
But the Earth isn't flat. It's bumpy.
It's bumpy.
Yeah, but the overall shape would be flat.
Yeah, the overall shape.
Flat's not a shape, though. Flat's not a shape.
Yeah, it is.
Are you fucking? You know what? I'm not even gonna bother.
Flat's a shape.
That's a battle for a different day.
Flat's a shape.
Yeah.
So.
Yes, flat is absolutely a shape. Sorry, but it is.
No, I don't think.
Yeah, I'm going to be plotting it on a flat surface. So let me find a place in South Oregon. Google Maps. Let's pick a city, just a random city. Say fuck it.
Well, you're going to be putting this on a bumpy Earth because the Earth is bumpy.
Yeah, but the sea level along it would not be bumpy, would it?
So what? You use a equatorial mount telescope on the ocean?
You can use it anywhere on the Earth. Yeah.
Yeah, you can use it anywhere.
saying that the Earth is flat. See, he's got me fucking stammering now. Saying that the Earth is bumpy is a way for bumpy nipples here to not be wrong. But I think you're still wrong anyway.
Yeah, I know.
Okay, so
But it doesn't work
38.
if the Earth
Hang
is
on, we have one
completely flat.
38.72 in Portugal. Thank you very much. I appreciate that. That actually gives me everything that I need. Okay, so let's go ahead and
Stupid.
let me save
It's
these two
stupid.
data points, and we will go ahead and graph this out and see if there is a contradiction with the flat Earth idea, theory, whatever the fuck you want to call it.
Earth's not
Personally, I call it bullshit, but you know.
Just call it bumpy Earth to make him happy. Even
Bumpy
though he has
Earth?
no idea what that means. Yeah.
You guys are strawmanning me.
No, we're not.
You said plot it out. That's exactly what we're doing. We're plotting it out.
Yeah.
On a bumpy
And
surface.
yeah, but the thing is, elevation above sea level would be flat on your thing. No matter what the elevation is, the elevation would be flat. All right. We all know that there's hills and valleys, but the elevation above sea level and sea level on your suggested version of Earth would be flat, and that is what we are basing this on. Okay?
Okay.
That's not a straw man.
Right.
That is your claim.
2 points. So let's go ahead and let me go ahead and make this out. So talk amongst yourselves. I'm going to plot this, and then I shall be right back.
Thank you. Wow, I'm sure you're getting dumber, Hip Hop Hippie. I'm not being mean, I'm just pointing this out factually. I think you are actually getting dumber. I mean, how do you still not get this? How are you still just cherry picking part of the words we are actually saying to you? That is literally the height of dishonesty. Why is the only way that you can debate by being dishonest? Why is that, in fact, the only way that flat earthers can debate, is by being dishonest? You're cherry picking. You were cherry picking part of what we were saying, not all of it, and saying that we agree with you, when no, we don't agree with you. Because if to agree with you, for us to agree, you would have to say that the Earth is a globe. Therefore, we do not agree. So you are lying and being dishonest. Why do you have to be dishonest?
But you say you don't see a geometric horizon, which
Absolutely
is your Earth curve.
No, okay.
It's not. Yes, it is.
No,
geometric horizon is your Earth curve. That's
no,
curve.
Again, it's not. It's an effect of the curve.
That's what
it's
you
not
say
the curve.
obstructs buildings and ships.
Yeah, an effect of the curve does that. You're right.
No, that would be the curve.
No, it's an effect of the curve, as I told you.
Be the curve.
The geometric
Look at this.
horizon
is the
curve.
No, it's not. The horizon is not the curve. This is actually a perfect example. Yo. It's... Actually, I kind of don't want to do that, but yeah, it's a perfect example of the curve. Bumpy Nipples here just doesn't want to admit it.
Is that the curve, or is that the horizon?
Well, you can see it curving towards the camera.
Yeah, but that bit, the actual bit that you can't see any further over, is that the curve, or is that the horizon? So or is this the curve, or is this the curve? Which bit? Is this the curve here, or is this the curve? Which bit is it?
They're both a curve.
All right. So what's this then? Is this not a horizon?
Yeah. You're saying it's the horizon.
And why is that horizon there? Why is that horizon there?
Because the container.
Because of what shape is the container?
Oh, it's a cylinder. I don't know.
It's curved.
It's like a puck.
It's curved.
Yeah.
The curve causes the horizon.
Curve.
No,
you said that the geometric horizon is not the curve.
Yeah, we said that all along. Why, if you reset, you're like a fucking robot that is short-circuited through water or something.
But you just said that the horizon is the curve, because
No,
the canister is curving.
No, I didn't.
Yes.
No,
So
I said the horizon, the point that you can no longer see past the curve is the horizon. The horizon is caused by there being a curve.
It's the curve.
If this shape, right, continued up this, I'm talking, shut up. If this shape continued up like this, right, in a tangent to this, and I showed you it like that, there would be no horizon. Because there is no tangent, because there is a curve, there is a horizon. The horizon is caused by the curve. Don't go back to that point, because that, again, is being dishonest. Stop being dishonest.
You're the one who says
that. No, I didn't say that. You're being dishonest again. You're being dishonest again. You're being dishonest again. Shut up. No, stop. You're being dishonest. Stop. You're being dishonest again. You have to use the entire word. You have to use everything that we say, not just part of it, or you are being dishonest. Every time you are dishonest, I'm going to call you out for being dishonest. Don't be dishonest.
Does the horizon obstruct things?
The horizon is an effect of the curve.
Does the horizon obstruct things? Yes or no?
Yes, it does.
So, how can something that's not a curve be obstructing something?
Because it's an effect of the curve. That's why it's obstructing things.
Because it is something.
Stop being dishonest. 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 Stop being dishonest.
It's because of the curve. And actually, I approve of this shit. I was not fucking letting him talk, because it's just, he's being dishonest.
Stop being dishonest. Stop being dishonest. Stop being dishonest. Stop being dishonest. Stop being dishonest. You're straw manning us.
You said it obstructs.
Stop being dishonest. Yes, it does, because it's an effect of the curve.
Which means it's physical. That's what you're saying. You're saying it's physical.
You cannot have a refracted horizon. You cannot have a
optical.
No. Actually, a refracted something can also obstruct something from your view, because that's how light works. All right? You are being dishonest by purposely not getting this point. Stop being dishonest. You would not have a horizon without a curve. The curve is the cause of the horizon. The horizon can obstruct things that are beyond it because there is a curve. Do you get it now? We are not going back to this again, all right? Do not ever on my channel say, is the horizon the curve again? Do you understand?
Well, you're saying that the horizon...
I asked you a question. Do you understand?
Yes, you're saying
you are banned from saying, is the curve the horizon or anything to that effect. Is that clear?
Why?
Because I told you so. It's my channel. Those are the rules. If you can't stick by it, you leave. You do not say again. We have gone over that. You are being dishonest by purpose not getting the point. So, you are banned from saying those words on my channel. If you bring up that point again, you will be removed. Is that clear?
Well, that's the only point that...
Is that clear? Is that clear?
You don't have a curve.
I said, is that clear, Hip Hop Hippie? Is it clear? Yes or no? Is it clear? Yes or no?
Are you going to rage kick me?
No, I'm asking you a question. Is it clear? Because now we move on to something else, like you providing evidence that the Earth has been measured as flat.
I never said it's flat. I said it's bumpy.
Yeah, elevation points are what we're going to go on, and elevation points on your, on your model.
So you
say it is.
So are you saying?
I'll let you know when you can talk. Thank you. On your model, or whatever you say you live on, even on your bumpy Earth, sea level and elevation points will all be flat. That is what we are basing it on. We are saying flat because elevation points and sea level will be flat. Therefore, according to you, the overall surface area of the Earth is flat because sea level would be flat. That is your model.
The Earth is bumpy.
Yeah. But what is would sea level be the same? Hold on. Would sea level be the same all over it? Yes or no?
Yes.
Right. Would 100 meters above sea level be the same all over it? Yes or no?
100 meters above sea level?
Yeah. Would 100 meters above sea level be 100 meters above sea level at every point?
Yeah.
Therefore, you are saying the Earth is flat. That's what we're going with.
Well, I'm saying it's bumpy.
No, okay. I told you. You have described your model. It is flat by all definitions. Reds, back to you.
So you got agree.
Anyway,
I said to Reds, you're not Reds. You're not Reds. You're not Reds. It's Reds' turn to talk.
Wait, I gotta address this.
No, you don't. You don't. You know, we're moving on from that. No. I'll mute you. I'll mute you. I'll mute you. I will mute you. Yeah. Okay. You're muted.
Thank you very much, Craig. Anyway, so what I did was I went ahead and found, and I'm actually going to plot a third point on this, but that'll be for later when we come back to this diagram in a bit. So anyway, I went ahead and found the two examples that was given in live chat. I'm going to share my screens right now. All right, let me know if you can see that.
Yep, we can.
Okay, so I was given two values from the live chat. These are people, I asked for people who own equatorial telescope mounts to give me how many degrees they need to set the axis, and I got Lipson, Portugal at 38.72 and 42 degrees for Southern Oregon or whatever. So with this, don't know why there's an end there, but with this, I went ahead and plotted out these 2 points. Now these points are, if we were to stack them on top of each other, would be 364 kilometers apart. So that's where I put them. A is at 0 and observer B is 364 meters. B is going to represent the Southern Oregon location. So I went ahead and plotted this out. I put this one at 38.72 degrees, put this line at 42 degrees. And here's the thing. If we were to zoom out and keep zooming out, and keep zooming out, and we were to keep zooming out over
Red,
and over
you must have done it wrong, because it looks like they're getting further apart.
Yeah, these lines are actually getting further and further apart. So, as you can see, as I go further and further up and out like this, they get further and further apart, which means in order for this observation to work on a flat Earth, the object that they would have to be looking at must be in two different places at the exact same time. Fascinating. But yet we know that these angles work in reality. Gee, I wonder why. Could it be that, I don't know, this more accurately describes reality?
So what happens if you zoom out there? Do they?
If I zoom out there, let's zoom out. Let's zoom out. Oh, look, they get closer. They get closer and closer and
that's
closer.
Weird. It's almost like they're converging to a point.
They are converging to a point. It's really fascinating. Now, I did put the star at quite a distance, but if we were to keep zooming out and zooming out and zooming out and zooming out, you would see that these 2 points would converge. These 2 lines would converge to a point.
How far away are you? How far away would you be from Earth?
Why does your mic sound shite all of a sudden?
Why does your mic sound like you're inside of a tin can's asshole?
Can you hear me?
Barely.
Barely.
You're technologically illiterate, so I understand.
Can you hear me better?
No,
you sound like you're inside a tin can.
Yeah, or an asshole.
We'll have to call back.
Yeah, you do that.
Hop on out and back in, I guess. But yeah, basically you get the idea. It's very fucking far apart. But yeah, that's exactly what we did with these 2 observations. Now, what I'm going to do is I'm going to stop sharing. I am going to put a third point on the flat graph. I'm going to put a third point on the flat graph. And when I do, I am going to come back. I'm going to screen share again, and we're going to see what happens to these sight lines. Do they converge? Do any of them converge on anything? Or do we get yet another contradiction? Stay tuned. I will be right back. Back over to you. Fight the flat Earth.
So just to confirm there, when you map out those things on a sea level that is flat, the angles based on reality don't work. But if you put those same angles from actual reality onto a curved surface with a radius that we say that it is, then it works.
And I know it's absolutely fucking amazing.
That would be
at first, but that would be
that thing called proof, wouldn't it?
I'm back.
Yeah,
Because,
basically,
you're back.
Now, you could flip the point.
And science, too, if I'm not mistaken. The act of actually plotting it out, wouldn't that be science? I don't know. I think it would, though.
Points. You can even flip the points completely 180 degrees, and guess what? They still wouldn't converge to a point. They would start to branch in different directions. That's the point. If you were to put an equatorial telescope out on a flat Earth, you get contradictions.
Well, we didn't see those converge to a point.
Reds just did it. Did you show it there, Reds?
I just did it. I literally just did it right here in front of you. What the fuck?
But this is
Anyway,
all.
Craig, back to you. I'll be right back.
Mm-hmm.
Yeah. Okay.
So let me reiterate the point there, Bumpy. So when we got angles from reality, from actual people that set up their equatorial mounts, and we asked them what angle they have to set it at, right? We then, based on their positions and distance apart, we mapped it onto a flat sea level, right? Which you will say that is what you have, a flat sea level, right? You said sea level be the same point all over whatever it is, so sea level would be flat, according to you.
You agree? So do you agree that sea level would not or would be the same?
If the Earth were flat, yes, sea level would be flat.
So are you disagreeing with that?
But we'll get to that. But we are saying that is that your point? Are you saying that sea level? Are you saying that sea? Wait, listen. Is your position that sea level is flat? Is that yes or no?
No, it's the same elevation.
Yeah, that means it's flat.
So do you disagree?
Well, we'll get to that. We're trying to point out a point right now. I just want to confirm. I'm just trying to confirm your position. Well, at this point, what I think is irrelevant. I'm just trying to confirm your position. You think sea level is flat, okay? We're going to go with that. So when you map out the angles that we got from reality, I'm sorry. Did the beginning of my sentence, I ruined that. Did the middle of my sentence interrupt the beginning of yours?
And you keep moving on.
You've clarified. You said sea level is the same elevation, which means it's flat. It would all be flat. No, elevation doesn't mean flat, but when you say flat,
you're saying that means it's flat.
No, I'm saying
you're saying that sea level is flat.
If the Earth is flat, that's my point. I'm not saying it is flat. I'm saying in your model, is it flat?
So sea level is not the same elevation on the globe?
That's not what flat means. Elevation doesn't mean flat. Elevation means a distance above a point.
So why would you say it's that? Why would you ask me if I think that's flat?
Because I'm asking you, do you think that it's flat? Do you think that sea level is flat? That it has zero curvature to sea level at any points? I think I may have used elevation in the wrong term there in my frustration with you being so stupid. Elevation means distance above a point, right? So if on your world is 100 meters above sea level flat, would 100 meters at sea level be the same here as it is over here, and you'd be able to see from 100 meters above sea level? Is that your position? The sea level and every elevation above it is flat. I just need a yes or a no.
Yeah. Do you
right?
disagree?
Okay, that's not the point right here. So
why would you answer that question though?
We'll get to it. It's not relevant to.
My chime card arrived today. Cool envelope. Welcome to the Chime family. Ooh. It's so clean.
To the point I'm trying to make, just listen, right? I'm asking you.
Why would you answer that?
Because I don't want to right now. I'm trying to make a point. Right, so
you don't agree that that's the case?
I'm going to ask you to stop talking while I'm finishing my point.
You don't agree that
I'm going to ask you to stop. All right, I'm going to have to mute you again. I'm going to have to mute you again if you don't stop talking. I am asking you to stop talking and let me finish my point. If you interrupt me once more, you will be muted again. Is that clear? All right, I'm going to take that as a yes. Right, do not interrupt me. We took angles from reality, from actual reality, and plotted them onto a flat sea level at 364 kilometers apart. And what we found out is that those angles would actually get further apart when pointing into the point in the sky. That is not what you interrupted me.
I understand what you're saying, dude.
Yeah, I did. Right, you get muted now while I finish my point.
I'm ready when you are, by the way.
Okay, I'm going to finish my point while he tries to constantly interrupt me. However, when we plotted those same angles onto a sphere, we found out that they did not get further apart. In fact, they converged to a point in the sky, matching reality. The only way that you could get the angles that we were given to match reality is to plot them onto a sphere, not a flat plane.
So,
all right. And sharing screens real quick.
Hold on 1 second. Hold on.
Yeah, let them respond.
So 100 meters above sea level is different from 100 meters above sea level somewhere else on the globe.
They would not be tangent to each other, no.
Tangent?
Yeah.
How do you have a tangent when you don't?
You don't know what a tangent is, do you?
What is it? It's your.
A tangent is a line off of the curved surface. That's all a tangent is.
Yeah. How do you have that line?
Because the Earth's a globe. Because the tangent can still exist.
How can you draw the line to that curve when you don't see it?
Because it's still there, and you can still have a tangent to something that you can't see.
And this is the part where I share it.
Yeah. So, right, Red, over to you.
So what I did, let me know if you can see my screen.
Yes, we can.
Perfect. Okay, so what I did is very simple. We have 42 degrees indicated in South Oregon. Thank you very much to that lovely person in the live chat. 38.72 degrees in Lipson, Portugal, and Astronomy Live. Thank you very much. 28 degrees in Tampa, Florida. These points are the correct distance apart. They are to scale as they would be in reality. These are to scale. The separation is to scale. So here you can see the 42 degrees, the 38.72 degrees, and the 28 degrees of Florida.
Why are they on the same line?
Because I'm modeling them on a flat Earth, dumbass. Shut up and look. If I were...
Be quiet.
Hold on.
No, if you talk once more, you get muted while Reds is explaining. You do not get to interrupt him explaining.
I'm trying to ask him a question.
You can ask questions afterwards.
After I'm done explaining.
Yeah, you either be quiet while he is talking or you get muted.
I modeled this to scale with actual real-life observations that have actually been done. We just did this. Now, if I were to zoom out and drag, oh look, the lines get further and further apart from each other. And if I were to keep going like this, the lines would be so spread out that eventually they're off the fucking charts. That's not what we see in reality. So basically, if we were to plot equatorial telescope mounts on a flat Earth, that's what this is. This is modeling a flat Earth. We get contradictory answers when we are pointing our telescope supposedly at the same object. How can one object be in 3 different places at the exact same time? Fucking magic, I suppose.
Well, all 3 of those lines aren't pointing at the same object, though.
That's the point.
They're all looking at the same object in our example.
What are they looking at?
Polaris.
But they're not all pointed at the same position.
Yeah, no shit. That's the contradiction. If you were... In order to look at Polaris in Florida, you have to angle your telescope at 28 degrees. In order to look at Polaris in Portugal, you would have to angle it at 38.72 degrees. And in Oregon, you would have to angle it at 42 degrees. All of these points are looking at the same object, which is Polaris. However, we can see that if modeled on a flat Earth, they give contradictory answers to the direction of Polaris.
Well, show Polaris on that graph.
Well, we can't tell where it is because they're not pointing at the same place.
They're not pointing. That's the point. You can't list an
in reality, they are.
Or Polaris.
Yes, in reality, they are. Yeah, in reality.
So this isn't reality?
No.
No, it's not, because it's modeled on a flat Earth. No shit, it's not reality.
The angles that were gathered come from reality, okay? But when you plot them onto a flat sea level, you do not get them matching reality.
Where's Polaris in this graph?
In Florida? Okay,
Yeah.
okay, let's answer this question one at a time. In Florida?
I just asked you a question, though.
We're answering the question. We are answering the question.
Please mute him. Please mute him. I am going to get through the answer without interruption. Polaris in Florida is 28 degrees above the horizon. In Portugal, Polaris is 38.72 degrees above the horizon. In Oregon, Polaris is 42 degrees above the horizon. All of these lines are supposedly pointing to Polaris. However, we can see that they don't agree with each other. However, if you were to model the same observation on a globe, they would agree with each other. They would all be pointing in the same direction. This shows that there is a contradiction with the flat Earth model that the globe model.
Sorry for not cutting in that much, but there wasn't anything to say. Hi. It's some things just speak for themselves.
Solves. Imagine that. Now you may ask your question.
You have to unmute yourself first.
Where is the horizon on that graph?
There is no horizon on a flat Earth.
You just said it's pointed. It's the Polaris is 28 degrees above the horizon.
In this case, on a flat Earth, it will be 28 degrees above the ground level.
Yeah.
What?
It'll be 28 degrees above the ground level. That's why I said 28 degrees above the ground level. You see this Earth that I modeled in green to let you know that it's the Earth? This line, 28 degrees above the supposed flat Earth.
Yeah, but you said it's pointing 28 degrees
above the flat Earth, supposedly.
Above
yes.
the horizon.
28 degrees above the flat Earth.
If it was a globe, it would be the horizon. But as it's the flat Earth, it's just...
Below.
So here
no, it is. You're wrong.
So here you can see the flat Earth. If I were to put this line way the fuck down here, if I were to put this line way the fuck down here, that would be 0 degrees. If I were to move it up like way over here, it would be closer to 45 degrees. However, where it is 28 degrees, which if you were in Florida, you would have to angle your telescope at 20 degrees in order to see Polaris. And it's different for Oregon and it's different for Portugal. But as you can see, even though they're all supposedly looking at the same object, they contradict each other. They don't converge to a point, they spread apart. This is the contradiction with the flat Earth model.
But they're not looking at the same object.
No, they
Correct.
are. They actually are. They just don't look like
in reality they are.
Flat Earth.
Yeah. On a world with a flat sea level, you would have 3 different Polaris. That's the point of this observation.
Correct.
Okay.
So basically,
if the Earth was flat,
Earth,
yeah, there would be a right. Move your cursor up, Reds. Oh wait, what happened? Where did that go? Did you stop sharing?
I stopped screen sharing.
All right, bring it back a sec.
Bring it back. Okay, hang on 1 second. I'm bringing it back.
That's awesome.
Yeah, I know. It's pretty fucking trippy.
Right. So put your cursor up to 300 at 3,000 elevation.
3,000 up, like right here.
Yeah. Right, and go along to the left. Right, until you hit one of the lines. Right. Stop. Right. So if the Earth and sea level was flat, you would have a Polaris here. Now go along to the left. A Polaris here. Now go along to the left. And
there's only one Polaris.
Exactly. That's the point.
That's a contradiction. In order for the observations that we get in reality to make sense on a flat Earth, you would need multiple Polarises at the exact same time. How can such a thing be possible?
I don't know.
Fucking magic, I suppose.
Wait, what's the plural of Polaris?
Why are all those points on the same line?
This is the flat Earth that I plotted them on.
But they're different positions, though, on Earth.
Yeah, no
Right.
shit, Sherlock. That's because they're distance apart. So, for example, Florida is this far away from Portugal. Portugal is this far away from Oregon if you're talking the distance between the equator and the North Pole.
But what's the equator?
The arbitrary line that they've decided is in the middle. There's an equator even on a flat.
What?
The middle between north and south.
I have to break things down. I have Craig. Do you understand what's happening here? This is me literally breaking out the crayons for this guy, and he still doesn't get it.
Another.
I am literally breaking out the crayons for you.
It's even simpler than that. It's fucking. I don't know how to. I don't know how to explain it. Simple. So let's just go with what Ed said.
It's not an ad-hom, it's a fact. You don't even know what an ad-hom is. It's a fact that we have to break out the crayons to explain things to you.
Distances are based off the equator.
I literally color-coded the ground for you, and you were like, where's the flat Earth? It's the fucking green line, douchebag.
Yeah.
Yeah, but all these points are on the same line.
They would be on a flat Earth.
We're modeling it on a flat Earth. We're showing you that there is a contradiction. The contradiction is that these lines are lines of sight. They're all supposedly looking at the same object, but yet they don't agree with each other. That's what happens.
Hold on. I think I know the problem here.
Flat Earth.
He doesn't realize this is an orthographic view. He's expecting there to be a circle for the flat Earth. I think that's the problem here.
No.
Well, then how do you not get?
First off, we don't see an orthographic view. So, if that's an orthographic view, then that doesn't translate anything to reality. Do we see an orthographic view?
Yes.
No.
Right now, I'm seeing an orthographic view of this book.
When you look at the globe, you don't see that. You're not looking.
Yeah, we weren't looking at the globe. But you could represent the globe. You can represent the globe. I'm talking.
That circle graph.
I'm talking. All right, I'll mute you. If you don't let me finish talking, I will mute you. Stop it. When I'm talking, you stop. Thank you. Stop behaving like a child.
Points.
Yeah. Wait, let me finish my point. Let me finish my point. If you represent the Earth in orthographic view, which is a possible to do, you can represent something in a orthographic view, it would be a circle. Right? It's as simple as that. Now stop being so incredibly rude as to constantly talk over me when I'm trying to give you an answer. Alright? You're like a fucking toddler.
Let's go ahead and take a look at this. What I've modeled here, the reason why the point...
You're gonna talk to me like that, dude?
Yeah, you're
You're gonna be rude to me after I've been rude to you for the whole time. This guy spent the whole fucking live stream fucking talking over this guy and interrupting him. And now he's getting all fucking butthurt. That's funny.
like a little toddler.
No, you're going to talk
why
to me
the
like
points
that.
are where they are.
It's like a toddler. You'll get treated like a toddler.
The reason why the points are where they are is that they represent their...
Rage quit.
The reason why the points are where they are is because they represent their position on a certain line of latitude. So this is accurate to its line of latitude. That's accurate to its line of latitude. This is accurate to its line of latitude.
Bumpy nipples is gone, but we're going to continue this anyway.
Latitude, so on and so forth, blah, blah, blah. However, also plotted is the angle at which they need to look in order to see Polaris. As you can see, there's a contradiction between all of them. So if you build everything to scale, it doesn't make sense on a flat Earth. That is the point. When you say they're not pointing in the right direction or they're branching away, that is the point. That's what happens when you model real life observations on a flat Earth. You get contradictory answers. So if the flat Earth renders contradictory answers, then the flat Earth must be bullshit.
Yeah, absolutely. And he ran away because he didn't like being treated like the toddler he was acting like. I just brought him here to troll him anyway. Rage Quit was kind of my...
that. At least I got to play with my graphing program. That was fun.
Yeah. I think it might be nice to do a video kind of trying to get as many of those observations as possible from as many people around the world that use equatorial mounts and map it onto both a flat and a globe.
Yeah, and I also want to point out something. People say, oh, the points should be in the opposite direction. They should be this, they should be that. It doesn't matter. Like I said, you can flip the points 180 degrees.
Yeah.
It doesn't matter. The point is that the lines will never agree with each other. There is no position on the flat Earth that you can put these points where they will agree with each other. It will never, ever work. Okay? You have a finite size to the supposed bullshit flat Earth, and you can put these points anywhere on the bullshit flat Earth. They will never agree with each other. And so, when I say equatorial telescope mount, what I really mean is the equatorial telescope mount is a fucking death blow to the flat Earth. Always has been, always will be.
Yeah. Bumpy Earth, hip hop hippie, whatever you want to call him, is so incredibly dense, or a Poe, but I genuinely think that he is as stupid as he appears to be. That he just can't grasp a simple concept. You know, I could explain that to my toe fungus, and it would understand with the amount of times we had to explain the same
Yeah, this guy is a complete idiot. I agree.
thing. Like, and then he went back to it.
Yeah, and here's the thing. He's like, oh well, the Earth is bumpy, so how do you know the proper angle and whatnot? Did you know that telescopes have these things built into them? They're called levels. You can actually level the telescope before you adjust your equatorial telescope mount to render those awesome images. And that's exactly what is done every single time an equatorial telescope mount is set up. It's not this thing that we haven't failed to take into account. No, terrain is a thing, and equatorial telescope mounts take those into account. And so, if you were to do this observation, you go to the southern tip of Florida, set up an equatorial telescope mount, take your measurement. Then you drive your happy ass all the way to fucking Maine or Canada, and you do that same thing. You set it up so you can get those awesome images again and see the angle difference. You can plot those on a flat Earth, and you will see a contradiction. Or you can plot them on a globe Earth, and you can see how they resolve that contradiction.
Magic. Right?
No, it's geometry. That's all it is.
That is magic. I've been told that if I use maths, it's wizardry, so...
Yeah, of course. You know, they like to say this shit all the time, but if you were to plot it on a globe Earth, there is no contradiction. The contradiction only manifests itself when you plot it on a flat Earth. Imagine that. But no, let's go ahead and ignore what we've been saying this entire time. Let's ignore the fact I had to break up the fucking crayons.
Robert Adset in the chat says, how much time do I spend conversing with my toe fungus? Well, after having a conversation with a flat earther, I do like to speak to something slightly more intelligent. So just to kind of help myself afterwards, I do spend a little while talking to my
Alright, so I'm gonna end it here. See you later.